Okay, so this is the video I was talking about for the calculation part of 14.3. I have 3 different examples on my notebook, and I'm going to work through them, but they are also the examples, either the one example that was given or the check your learning on chapter 14. So 14.9 is the first example that's check your learning. The second one's going to be the check your learning that's found in example 14.11. And the third one I'm going to do is from 14.12. And the reason why I'm doing that one is because there's a typo in that example, but it's a good example except for this typo that I'll point out when we get there, okay? Now, I haven't worked through these before, but hopefully nothing will go completely wrong with the answers. If you catch something, let me know, but I'm going to try to be thorough and correct, accurate and precise. So the first one is determining Ka or Kb. It really doesn't matter which one we're calculating. Just remember, the Ka is reserved for acids, and Kb is reserved for bases. So A for acid, B for base, K for equilibrium. So I have this reaction. I have HSO4 minus reacting with water, making hydronium, and SO4 2 minus. So from left to right, I'm losing my acid, or losing my proton, making this my acid, my conjugate base, my conjugate acid. Okay, so I would recommend on a lot of these practice earlier concepts, like identifying acids and base, and don't just treat that as one question. Try to layer these questions if you can. Okay, so in my question I was given concentrations at equilibrium. 0.29, water is told to be a liquid, meaning this value is going to be a 1 in my equilibrium equation. And then I was given that it's 0.027 and 0.13 for both of my products. Okay, I want to know what Ka is. I know that it is Ka and not Kb because this is H3O plus. If it was a Kb problem, it would have OH minus. Okay, so that's how I knew that this was Ka, besides the fact that it told me. So I set up my Ka expression with my products over reactants. And remember, all equilibrium Ks are always products over reactants. The only thing the A tells us is that this relates to acids. The B tells us it relates to bases. The C's was concentrations. The P's was for pressure. Okay, we're going to keep building on this K concept. But remember, they're always products over reactants. So I'm going to plug in my values that I was given at equilibrium. And what I get is this. I have 0.027 times 0.13, and that gives me 0.00351 for my numerator. And I'm going to divide that by 0.29, which gives me 0.0121. For my KEQ, or you could break that down to scientific notation. And I'm going to highlight it. And that's my KB. Okay, so you may think, well, that was just the easiest problem ever. But if you go back to chapter 13, the very kind of first math problems we did were identical to this. Okay, so those two examples are very similar. Okay, my next one is determining Ka or Kb from pH or POH. Okay, so it can be any combination of those. So the first thing that I'm told is that the pH of a solution of household ammonia is 0.950 molar, of a 0.95 molar solution of ammonia is 11.16. So this is my pH, this is my concentration, and it wants to know Kb. So it didn't give me this formula, but ammonia is NH3. I'm looking for Kb, so we're going to treat this as a base. It's one of our not strong bases, but our most commonly seen weak bases. All of these Ka, Kbs typically have the base or the acid plus water. In this case, since this is my base, it's going to be my proton acceptor, meaning from left to right, it's going to gain a proton and a charge to become NH4 plus. And then water loses a proton, becoming OH minus, again confirming the presence of OH, that we're looking for Kb instead of hydronium H3O plus being for Ka. Okay. So and I want to point this out. So water, because it's a liquid, is completely crossed out. So I went ahead and just put a line all the way through my ice table. I have my ice table with initial, change, and equilibrium, and I drew a line to divvy up my table a little bit. Okay. So the first thing that I'm going to do is take my pH of, or the concentration of my ammonia. It's what I'm starting with. Okay, 0.950. Now, initially, I'm not going to start with anything